Hello there. Today we are going to be taking our time to talk quickly about leveraging engineering and automation in a data role. Let me quickly share my screen with you. 2 seconds. The reason for it was in different data roles, whether you are as a head of data or a modern chief architect, whether an enterprise architect or a chief data architect, your responsibility goes beyond single domain in data space. You touch several different areas in data, and today we are going to be covering how the engineering can actually can help, how the engineering and automation can actually help you in your excuse me, in your data role. So 6 key topics we are going to be talking about. They're the most important ones, in my opinion. Um, but there is a good opportunity to disagree with me here as well. There are several other topics we need to be aware of, but for a 10-minute presentation, I've picked up the top 6. We're looking into data ingestion. We'll talk a little bit about it. Data transformation, quality of data, etc. Data storage is a key element of any data role. We discussed data pipelines. We will look into the governance side of it. And the hot topic, we look into the visualization of data. So for data ingestion, so I've been working in engineering capacity over the last 18 to 20 years, and really started my career as an engineer, ingesting data, writing manual SQL to start with. But with a few things that we didn't need to think about when we are talking about data ingestion as a topic is how to capture data seamlessly from diverse sources of data. So we can build data sharing tools using APIs, for example. We can structure the database in a way that the data is more understandable, linkable, in a star format, for example. We have streaming platforms that could produce event-driven data as well. For example, in my experiences, I've worked in the gambling sector, and they have a lot of event-driven data architectures. It's quite flexible. Sorry, I've got a bit sore throat today. Right, and what we want to ensure is that data is transferred reliably and securely and efficiently. We can use technologies like cryptography, zero-knowledge proofs, multi-party computation to make sure the data is being safely and securely transmitted between the two or more than two organizations sharing a link of data. Quickly going through tools and techniques, various different methodologies available. I've used Kinesis in the past. Kafka, there are managed Kafka services in AWS as well. Plus, you can use Kafka on any cloud platform as well as a service. We can use Flume to collect data and log data. So several cloud data services we can look into. Kinesis, as I mentioned, Azure Event Hub is quite popular nowadays. GCP folks can look into other options. The challenges a head of data or a chief role look into addressing is scalability issues with increasing data volumes. As we move forward in 2025, AI is going to become even more part of our automation processes. That would mean the data is going to significantly increase. We have capacity to handle real-time data for changing business needs as the business evolves and enter new markets. And we need to make sure that the integration of different data formats is possible via different toolings and methods we'll touch on in the next couple of slides. Now, data transformation for any head of role is a very, very problematic space, because over here, what we want to accomplish is ensuring data is highly available and reliable. Basically, we are saying that the quality really needs to be trustable, and we have defined our standards. It's optimized for storage, and the formatting is done in a way that is storage friendly and cost effective in performance, especially in the public cloud. It's very, very costly to store data. For example, S3 buckets. They seem cheap when you talk about petabytes of data. It's just quite expensive. And easy access, easy access for any workloads. It's easily accessible via API, which we talked about in the integration slide previously. Storage options, carefully look into your storage, what storage opportunities are available in all platforms like Azure, S3 buckets, and AWS, GCP cloud storage, to scale out as and when you need, and on the fly autonomously. Consider using data lakes. There are data lake concepts and data warehouses. Whatever is your preference, make sure the unified repositories are structured, and unstructured data. Snowflake, Redshift, BigQuery. In the past, I've used Hadoop, EMR. You can look into that as well. AWS Glue is becoming quite popular. Optimization techniques for your team. You should consider using columnar formats like Apache Parquet or other different formats available for analytic workloads. Here's switch for cost effectiveness. I think that's quite interesting, because not all of your data is hot data. A lot of data is quite static. It's not dynamic. It's not changing on the fly. And that kind of data could be considered cold data. And there are several different options to use as a storage to optimize cost. Best practices is implement disaster recovery solutions. Make sure you test them every 3 months. Not really there to wait it out for actually disaster to take place. This is very, very important to take the backups and test those backups. You can automate those, but also what I normally do is every 3 months I conduct a real life disaster recovery failover, if I need to. Encryption at rest is very critical, and that should come as a common standard practice. Yeah, data pipelines. So data pipelines is a very complicated topic. We might just like to cover into as a masterclass in the future, but for today, just very, very quickly, data pipelines kind of for workflows where smooth transfer between data from different sources taking place. We talked about APIs in the integration slide deck, and basically we are implementing automation, consistency around the transformation of data, sharing of data, and the tools are quite consistent and it's quite scalable. Governance is a topic very, very close to my heart. I have worked a lot in this over the last few years recently. So any head of role should focus on implementing policies and best practices to maintain data accuracy, compliance with different bodies, the need to regulatory bodies. And the primary objective should include protecting sensitive data from breaches, and upholding high quality standards. There could be data standards, could be data attribute standards, or any other industry practice standards that you want to implement. Very briefly, just skimming through it, make sure it's secure, protect sensitive data through access controls, make sure it's compliant with GDPR, HIPAA for US, for example, and everybody knows that who owns what data. And this could be done by a data catalog, a metadata catalog. I've done a separate masterclass on that, and it's auditable. The data logs you can use, Gray logs or Splunk or anything else to make sure your audit logs being collected for be able to audit data, to be able to share data with auditors as well if you want to. Data visualization. When you have raw data, you want to visualize that. You want the stakeholders to have a clear understanding of what insights they want from the data. The four key topics would be for me: need to have clarity. You need to understand what tools you want to use, and you standardize those tools like ClickView, Tableau, Power BI, whatever is suitable. Um, and customization is in place. For example, C-suites would not really want to run SQL themselves. They would want dashboards that works for them. Whereas product owners would want a different level of customization. Actionability, so there is focus on insights that drive strategic decisions. Um, we will leave it there, and I'll take your feedback and maybe deep dive into some of the topics. So each of the topic in there was worth a masterclass on its own. But this presentation was more about what key things a head of data or chief architect should have in mind when they're running their practice, their data practice. Myself, seasoned leader in data. I've been engineer, analyst, scientist, architect, um, and I've got cloud certifications. Certified TOGAF, architect as well. I've deployed large-scale platforms in different organizations. I'm author of Data Evolution. I talk about a lot of data stuff in many different conferences, and I hope to see you in some of those conferences in the near future. Thank you very much for taking the time to attend the masterclass here today, and we will look into a couple of those topics in more detail over the coming weeks. Thank you very much, and have a good day. Thank you.